I welcome you all in this online course on manufacturing processes. I am Kishore Kumar, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So today we are going to talk about the solidification time. We will see what is the meaning of solidification time. Then we will of course see how to calculate this calculation time. And based on this concept, we will take few numericals so that whatever we will discuss, it will be clear through numerical. So first we are starting with the solidification time. First of all, we'll see in casting what is the meaning of solidification time. As we all know, during the casting, molten metal is poured. So that molten metal through all the gating system finally it reaches to the mold cavity. So if we will draw the diagram, so through that we can understand. Suppose this is the pouring basin and this is the sprue. This is the pouring basin and this is a sprue. This is the runner and suppose this is the mold cavity. So suppose we are pouring metal from this one, molten metal. So through this it will go inside and finally it will be filled inside this mold cavity. So how much time that molten metal will take to reach to this mold cavity, and once it will reach over there, after that how much time it will take to change its state from solid to liquid, this is known as solidification time. So if you calculate, or if you are drawing through the graph and try to find out how to get this, so we can find out. Suppose this is the graph we are plotting. This is the graph we are plotting. Here this is the time, and if this is on vertical temperature, vertical axis it is temperature. So suppose we are drawing the diagram, so it will look like this one. So this will be the pouring temperature at which the molten metal is poured over there, and once it will be poured over there, it will start freezing, and once it will reach at this point, freezing will start. So from this point to this point, once it will reach here, completely it will be in the form of solid at this point. In between it will be solid and liquid. So it's not about reaching at this point, at the room temperature, the temperature where we are performing the experiment. So solidification time is when we are pouring, that is the pouring temperature starting from here to reaching at this solid state, not at this room temperature or the temperature where we are doing the experiment. So how much time it is taking from this point to this point, this is known as solidification time. So if we have to calculate how much heat will be evolved or how much heat will be lost over there, so easily we can calculate. In this phase, as we know that temperature is changing from this pouring temperature to this freezing temperature. So we know how much heat will be evolved. We know we can write Q is equal to mc delta T, where this m is the mass of the liquid or the molten metal that we are pouring over there, and c is the specific heat of the metal, and delta T of course is the temperature difference between this pouring temperature and the temperature where the freezing starts. But as we know, between these two, the material is in mixed form. Mixed form means some part of it is in liquid state and some part of it is in solid state. So in between, the temperature change will be, we know if we are writing this one Q1 and if we write this one at Q2, so this Q2 will be M into L. So this is actually mass of course the liquid metal, and L is the latent heat of fusion. So to reaching, once it will reach at this point, finally it will be in solid state. So how much time it is taking from this state to this state, reaching to this state, when the liquid has completely transformed into solid, this actually time is known as solidification time. So this is about solidification time. Most of the students generally are in confusion that solidification time is the time where we are pouring the metal and finally when it is reaching to the room temperature. No, this is not the room temperature. It is actually the point up to where the complete liquid has transformed into solid state. So whatever the time it is taking, this is known as solidification time. So what is the formula or what is the method how to find out? Actually this is based on experimental data. So this solidification time, if we write T, so this T is given as some constant. Suppose we are writing gamma into volume upon surface area and square of this one. As I told, this is a experimental data. Experimental data means there is no proof for this one. So this solidification time is given as T is equal to this solidification constant gamma into volume of the metal which we are pouring, and surface area, the area through which heat actually is dissipating, means heat is coming out from the area or the mold. So this is the volume upon surface area. This is also known as modulus. We'll see for in later classes. So this is a constant actually. Gamma is a constant. Gamma is a constant. It is totally dependent upon the material that we are pouring, and V is the volume and A is the surface area. So, and T is of course the solidification time. Solidification time. V is the volume, A is the surface area. So through this one easily we can calculate the time, how much time a metal will take when it is in liquid state to reach in solid state while doing the casting. So to make this concept more clear, we will take a numerical, so things will be more clear. So we have taken this numerical. This is actually a gate numerical, gate question. It is it was asked in gate 2013. So from there I have taken this one. This was actually in 2 marks, but this is totally based on the concept what just now we discussed, how to calculate the solidification time. That's why I have taken this numerical. So first we'll read and analyze what is there and what we have to calculate. So a cube shaped casting solidifies in 5 minutes, means cube shaped casting is there. For solidification it is taking 5 minutes. The solidification time in minute for a cube of same material. Now we have another cube shaped casting of same material. Suppose this first casting is made up of aluminum, the second one is also made up of aluminum because material is same. If first one is cast iron, so second one is also cast iron. It has been given the material is same and shape is also cube shape, which is 8 times heavier than the original casting. So what the question is, first one we have a cube, okay now, and second one also is having a cube. Okay, this is the first one which is given. It is taking solidification time for this one is 5 minutes. Second one we have to calculate how much it will time, how much time it will take for solidification in minute. The condition is given. This second one is means if we are writing volume V2 for second one and volume V1 for first one. So it is given that V2 is equal to 8 times of V1, means its weight is 8 times. I am writing volume is 8 times. If we will see, so we can easily find out weight is nothing but, if we will write that this W weight is equal to rho into V into G. We can write weight is in fact mass into acceleration due to gravity, and for mass we can write rho is density and V is the volume and G is acceleration due to gravity. So we can see here this rho for a given material which is constant, and of course a small g is a constant, that is acceleration due to gravity. So from here we can see that this W, that is weight, is directly proportional to volume. So in the problem it is given that it is 8 times heavier than, so that weight we can replace by the volume. So second casting for which we have to calculate the solidification time, it is actually 8 times heavier than the first one, that is V2 is equal to 8 times V1. So we have to calculate this T2. So we know the formula, easily we can calculate. If I have given this V2 is equal to V1, and if we are assuming that this cubical shape have a side length of a small a, if we are taking this has side length of a small a and this has actually capital A, so we can write volume for this one, and this small V2 for second one we can write volume for this one is A cube, and this will be equal to, for this one we can write this the volume for this one is A cube and this one will be 8A cube. So from here we can get the relation capital A is equal to twice of a small a. So from here we can, if we take the ratio, we can write a small a upon capital A is equal to half. Now we can apply the formula. The what formula that we have just now we learned that how to calculate the solidification time, that T is equal to gamma times volume upon surface area and a square of this one. So gamma V upon A square of this one. So from here, as this gamma is constant, so we can write T is directly proportional to volume upon surface area. So if we are taking T1 time for this cube shaped one and T2 time for the second one, so we can write the ratio T2 upon T1 is equal to, we can write from here V2 upon V1 into A1 upon A2 and whole square. We can write this one. So from here, from this relation, we can write V2 is nothing but 8V1. So from here we can write 8V1 upon V1 into, and this A1 is nothing but this is actually a cube which is having 6 square faces. So area will be 6A square. So we can write 6A square, and similarly this is having also 6, but here the side length is capital A. So this is 6 capital A square and whole square we can write. So this B1 and V1 will be cancelled out. This 6 and 6 will be cancelled out, and this ratio a small a square upon capital A square, we can write a small a upon capital A whole square. So this whole expression can be written as in bracket 8 into a small a upon capital A square of this one. We can write this one. So this capital A. So now 8 into a small a upon capital A, this whole square, and we have already seen that this small a upon capital A is nothing but a half. So we will take this one on second page. So we can write T2 upon T1 is equal to in bracket 8 into this small a upon capital A whole square of this one. This whole square is equal to 8 into, and this small a upon capital A, from here we can write half. So this is half a square of this one and this whole square. Okay. So from here we can see this 8 into this 1 upon 4 and this is whole square. So this is will be 2 times. So it will be a square of 2. This is actually 4. So from here we can write this ratio T2 upon T1 is equal to 4, and T1 is given in the problem. We can see from here T1, the first casting, which is taking 5 minutes. So this value will put here. So this implies this T2, the time taken for the casting 2. This will be equal to T1 into 4, and T1 is given in the problem, it is 5. So 5 into 4, and this will be 20 minutes. So this will be answer for this one. So the second casting, which is actually 8 times heavier than the first one, will take 4 times more time to solidify if we compare with the first one. So in this problem, we saw how we can use this formula, this solidification time formula, to find out how much time a casting will take during its solidification. And through numerical, this numerical was a great problem. Also we saw how to what is the meaning of solidification time through this diagram. So main in this was to understand solidification time is not from the point where we are pouring the metal and the point where finally it is reaching, means wherever we are doing the experiment in the lab, so that room temperature or experiment condition temperature, that is not the point. The important point here to understand, when the metal is completely transformed from the liquid to the solid state, that time we have to consider at the solidification time. So I hope this was understandable to all the students. So next we'll take it further when we'll take the more complicated cases, and we'll also consider not only the mold cavity, rather we'll also consider when riser will be there, and in riser also if different conditions are imposed over there, that one side is insulated, another side is insulated, now what will the solidification time in that cases. So in next lecture we'll take more complicated cases, I mean the numerical based on when the riser solidification time will also be involved over there. So for today we'll stop here. Thank you for watching the video.